Alright, so now we'll look at methods of partial fractions. Now these are methods of how we actually create partial fractions. So the first method is for those that have a denominator with only linear factors. So now linear factors refer to the factors of a polynomial that are of degree 1. In other words, they are expressions of the form ax plus b, where a and b are constants and x is the variable raised to the power 1. So take note, we cannot have a value like x squared, we cannot have a value like x plus 1 squared. So these ones are, so what happens is when we factorize completely, we'll end up with the values at the end only being linear and being in this format where the highest power of x is only raised to the power 1. But we'll see that from these examples. So let's look at the question number 1. So being told to express 3x over x minus 1 times x plus 2 as a partial fraction. Now I can already clearly see that this is actually a proper fraction, so we can actually proceed forward. Now we can actually see what we mean by linear factors. So x minus 1 is a linear factor because we don't have x raised to a power. Then here we also see that x plus 2, x is also not raised to a power. So this is actually a denominator with only linear factors. So what do we do? So we're going to let 3x divided by x minus 1 plus times x plus 2 be equal to a over x minus 1 plus b over x plus 2. So what happens is, in this case, after factorizing the denominator completely into linear factors, actually we already have linear factors from the beginning, we write the fraction as the sum of two simpler fractions. So these are the two simpler fractions. So the first fraction is a divided by x minus 1 plus b divided by x plus 2, where each denominator you can already see is one of the linear factors. So we have this x minus 1 and we have this x plus 2 for the denominator of each of the two fractions. So next we'll assign unknown constants to the numerators of the simpler fractions. So we've assigned a constant, an unknown constant a and an unknown constant b. So now the next step shall be to find out the values of a and the values of b, and then once we know the values of those unknown constants, we now have the partial fractions. So how are we going to do that? So first of all, we're going to find the LCM on the right hand side. So the LCM is going to be x minus 1 times x plus 2. So when we get this value here, divide by x minus 1, we have x plus 2. X plus 2 times a, we end up with that. Then when we get this denominator, divide by x plus 2, we are left with x minus 1. X minus 1 times b is b into x minus 1. So now we have it as 3x being equal to a times a into bracket x plus 2 plus b into x minus 1. So now we enter a very, very important step. Now we need to find the values of a and b. So now we're going to let x to be certain values. We're going to use some form of elimination method to find out the values of a and b. So when you look at the values here, you can ask yourself a question. Let's assume we want to find the value of a. What do we do? What value can we input? Let me get my marker. What value can we put if we want to find the value of a and we want to eliminate b? You can actually set, if we let x be positive 1, this will become 1 minus 1, which is 0. 0 times b shall be 0, and then with that we can actually find the value of a. So we can actually see that we can, so if we want to find a, we shall assign b as 1, and then we can also set, if we want to find the value of b, when you look here, you can actually set what value can we insert here, and then this will become a 0. So you can actually say that value is negative 2. Negative 2 plus 2 is 0. So when you insert that there, we'll have that being 0, and we can find the value of b. So now we can let x be two different values. Either we're going to start with 1, and then we'll have x being equal to negative 2. Alright, let's start with x being equal to negative 2. If x is equal to negative 2, we can already see that this is what we end up having. So now we're going to have a 0 here. We'll have a 0 multiplying the a. Then here we have a 3 times negative 2, which is negative 6. And then negative 2 minus 2 is negative 3. So that's why we have a negative 3 right there. Now this disappears because 0 times a is 0. So left with negative 6 is equal to negative 3b. So therefore b shall be equal to positive 2. So now remember that the next value that we shall let x to be is 1. So let's move on to that. So if x is equal to 1, we can actually say this is what we end up having. So we'll have 3 times 1, which is 3. then we'll have 1 plus 2 is 3a, then 1 minus 1 obviously is 0, so the b shall cancel, so we're left with 3 being equal to 3a, of which a shall be equal to 1. And now we found both of the values of a and b, so therefore this is how our partial fraction is going to be. So we'll have it as 3x divided by x minus 1 times x plus 1 shall be equal to 1 divided by x minus 1 plus 2 divided by x plus 2. So this is the value of b, which is 2 that we found, and this is the value of a, which is 1 that we found. And that's how we express this as partial fractions. All right, let's look at another example. So this is another clear example. So you can already see it clearly. This is an example of a proper fraction, because clearly when you open the, imagine you open the brackets, the denominator, you can actually see that we'll have x squared somewhere. So this is clearly a proper fraction. So you can express this as a partial fraction directly, and you can already see that we can actually no longer factorize this further because it's already clearly. So this is already clearly linear factors. So again, going to let that be equal to a over x minus 3 plus b over 2x plus 1. So now next to find the LCM, and this is what we shall end up having. So this shall be our LCM, and then next we shall see that these denominators actually cancel. So this and this cancel, and we're left with 3x plus y being equal to that. So now the next step is, now we ask ourselves again, now we're going to use that elimination method again. If we want to find the value of a, what value can we let x be equal to b? So we can actually say that if we can let x be equal to 3, if we let it be equal to 3, we can actually eliminate b and we can find the value of a. Then we can also see that if we look, if we want to find the value of b, what we can actually clearly see is if we multiply, so what value can we put here to make this a 0? So you can actually say that has to be a negative a half, because negative a half times 2 is going to be equal to negative 1, and negative 1 plus 1 shall be equal to 0. So now we have 3 and negative a half as the values they shall use. So first of all, we're going to let x be equal to negative a half. So now we're going to insert in the value there. So when you insert in the value, this is what we end up having. So let's keep on simplifying, and we're left with 7 over 2 being equal to a times 0 minus 7 over 2b. So you can already see that we'll have 7 over 2 is equal to negative 7 over 2b. So b shall be equal to negative 1, and that's going to be our first value. So now next we're going to let x be equal to 3. So when you let x be equal to 3, we can actually, this is what we end up having. So when you open those brackets, we have 14 is equal to 7a minus b times 0, which is clearly 14 is equal to 7a, so a shall be equal to 2. So now we know the value of a and we know the value of b. So therefore 3x plus 5 divided by x minus 3 times 2x plus 1. So now it can be simplified as, so this is how it looks when it's simplified: 2 over x minus 3 plus negative 1 over 2x plus 1. But now I can actually say that I can actually bring this negative and it will affect this plus sign, so we'll have it being expressed this way. So this becomes our final, this is how these are the partial fractions that we actually derive from that general fraction. So this is how it looks in simpler form. All right, let's look at another example. Now we have, this is actually slightly different. If we have x minus 1 divided by 3x squared minus 11x plus 10, they're being asked to express this as a partial fraction. Now you can already see that now at the denominator we'll actually have an x squared. Now this is actually not clearly in linear factor form, so you can actually see that now that we have a quadratic equation at the bottom, we ask ourselves, can this be factorized or simplified any further? And actually you can actually see that yes, it can. So you can actually say that can be simplified as that. So now let's consider 3x squared minus 11x plus 10. So you can actually say that this, let's simplify this quadratic equation. So we can actually convert it into 3x squared minus 6x minus 5x plus 10. Of course, these both add up to become negative 11x. So when we factorize out, we have 3x into x minus 2 for these 2. Then we have a negative 5 factorized out for x minus 2 right there. So it can actually be simplified and it will look like this. So it will be 3x minus 5 times 3x minus 2. And these are linear factors. So that means we can let x minus 2 over. So now this is how they look in linear factor form, being equal to that. So now when we find the LCM, this is what we end up having. So now we can actually say that these denominators cancel and we are left with that. So now what values can we use to find the value of b. So actually when I want to find the value of b, I can actually say that all I have to do is make the value of x be equal to positive 2, and then the a will cancel. If I want to find the value of a and I want to eliminate b, actually I can already clearly see that all I have to do is all I need is a 5 divided by 3. So I need a 5 divided by 3. It will allow that value here to cancel. So let's start with x being equal to 2. So if x is equal to 2, this is what we end up having. So we can actually say that we have 1 being equal to that. So b shall be equal to 1. So now next we shall make bx be equal to 5 over 3. And we can actually say that this is what it looks in a simplified format. So open the brackets step by step, and we'll have 2 over 3 being equal to negative 1 over 3a, of which a shall be equal to negative 2. So now we end up having this. So now x minus 1 over that. So this is how it will look. It will be equal to negative 2 over 3x minus 5 plus 1 over x minus 2. And that's going to be our final expression. Alright, so moving on to question number 4. Now this looks slightly complex, but I can already clearly see that this is also a proper fraction. So we can actually proceed forward. Now we can already see that at the denominator, every value is already expressed in linear form. So we don't need to simplify the denominator any further. So that is okay. So now this is what we have. So now we're going to let that value be equal to that. So now we're going to have, we're going to assign an unknown constant to each one of the denominators. So that's what happens there. So we have a over that, b over that, and c over that. So now we'll have 3 unknown constants that we actually have to solve for in this case. So now when we find the LCM, now this is a little bit more tricky, but this works out. So when we find the LCM, so this is going to be our LCM. So when we get this value, divide by x plus 1, we are left with x minus 2 and x minus 3. So when you get this value here, divide by x minus 2, we are left with x plus 1 and x minus 3. Get this, divide by x minus 3, we are left with x plus 1 into x minus 2, and that's what we multiply right there. So now you can already see that the denominator values cancel, and this is what we are left with as our general equation. So now we can actually now ask ourselves, what values can we insert to find different values? So now I can already clearly see that if I want to find the value of a, all I have to do is to let the value of x be equal to negative 1. So when I let the value of x be equal to negative 1, you can actually say that this will cancel and this also will cancel. How about if I want to find the value of b? I can actually see that all I need to do is make x be equal to positive 2. And that's how we'll find the value of b. Then if I want to find the value of c, all I have to do is to let the value of x be equal to 3. So when I let x be equal to 3, I can already say that this and this will cancel. So we have a negative 1, 2, and 3 as the values we shall let. So if we let x be equal to 2, this is what we end up having. So this is how it looks in a more simplified version. So we end up having negative 6 being equal to negative 3b, of which b shall be equal to 2. So if we let x be equal to 3, this is what we end up having. Simplify it, and we have c being equal to negative 3. Then lastly, if we let x be equal to negative 1, we'll have that, simplify it, and we'll have 48 being equal to 12a, of which a shall be equal to 4. So therefore, we'll have the final expression as partial fractions being equal to 4 over x plus 1 plus 2 over x minus 2 plus negative 3 over x minus 3. Of course, bring this negative sign and it will affect this plus sign, and this is what we end up having as our final answer. Right, question number 5, we have 32 over x cubed minus 16x as partial fractions. We are being told to express it that way. So this is already a proper fraction. So solve this, we have 32 over that. So this we can already clearly see that now we can actually still factorize out an x right here. So when we factorize out an x, we are left with x into x squared minus 16. But we can already see that this one is also a difference of 2 squared. So it can also be factorized or simplified further. So when you simplify it further, we're left with x into x minus 4 times x plus 4. So now these are now in linear factor form. So this is how they look when they're simplified further. So now we can let 32 over that be equal to a over x plus b over x minus 4 plus c over x plus 4. So now when we find the LCM, we can already see that this is definitely our LCM. So our LCM, this divided by x is going to be equal to x minus 4 times x plus 4. This divided by x minus 4 is going to be equal to x into x plus 4. And then this divided by x plus 4 is going to be equal to x times x minus 4. So now these denominators now cancel, and then we're left with 32 being equal to that. So now we ask ourselves the question, what values can we insert if we want to find some different unknown values? So first of all, you can already clearly see if I want to find the value of a, all I have to do is let the value of x be equal to 0. So if I let the value of x be equal to 0, you can actually see at 0 times this cancels and this cancels, and then therefore we'll find the value of a. And then you can also set, if I want to find the value of b, all I have to do is to let the value of x be equal to 4. So when I let it be equal to 4, c and a will cancel. Then if I want to find the value of c, all I have to do is let the value of x be equal to negative 4, as I can already see from here, and then this and this will cancel. So now so if we let x be equal to 4, this is what we end up having, and then we can actually find the value of b. So b shall be equal to 1. So if we let x be equal to negative 4, and then we insert it in, this is what we end up having. So c shall be equal to 1 also. Then lastly, to find the value of a, if we let x be equal to 0, we have 32 is equal to negative 16a, of which a shall be equal to negative 2, and that's going to be our value of a. So therefore, this is what we have as our final equation, and that's how we have it in partial fractions. Alright, let's look at question number 6. Now question number 6 is different. We're being asked to integrate this partial fraction. So we're being asked to integrate 3x plus 1 over x minus 2 into 2x plus 1. Now this is a unique kind of integration number because we cannot apply any of the rules that we had applied before. We cannot clearly just apply trigonometric substitution or U substitution or any other like that. So this is an example. So this is a partial fraction. I mean, this is a complicated fraction that has to be first expressed as partial fractions before we integrate it. So we're going to first express this value here as partial fractions. But good enough, we can already see that this is actually one with linear factors already. So it doesn't need to be simplified further, and it is also a proper fraction. Alright, so now first of all, the first step we're going to do is we're going to let that value be equal to a over x minus 1 plus b over 2x plus 1. So now we're going to find the LCM. So this is the LCM, and then the denominators cancel, and this is what we are left with. So now we can already set to eliminate, if I want to find the value of a, all I have to do is to let x be equal to positive 1, and the b will cancel. Then if I want to find the value of b, all I have to do is to let the value of x be equal to, let's see, it's going to be equal to negative a half. When I let it be equal to negative a half, the a value will cancel. So if x is equal to 1, this is what we end up having, and 3a shall be equal to 4, of which a shall be equal to 4 over 3. And then if we let x be equal to negative a half, we can actually see that this is what we end up having. So the a values cancel, and we're left with negative a half being equal to negative 3 over 2b, and then b shall be equal to a third. So therefore, this is how we have our fraction. So now we have 4 over 3 over x minus 1 plus 1 over 3 over 2x plus 1. So you can already see that these denominators here actually go to the general denominator. Then they can be expressed that way. So now this is what we have as our partial fraction. So now these can now be integrated. So we're going to integrate the partial fractions. So now when we integrate them, this is now what we end up having. So this is the same as the integral of 4 over 3 into x minus 1 plus 1 over 3 into 2x plus 1. So now clearly we can already see that we can actually separate this into two different fractions. So this can be separated into two different fractions, of which this is what we have, this and that. So from here we can actually factorize out 4 over 3, and then you can factorize out a third. Then this is what we end up having. So now this can easily be integrated. So now this is easy to integrate. This can be integrated using U substitution, and you will have 4 over 3 ln x minus 1. Then this can also be integrated using U substitution, and it's going to be equal to a half ln 2x plus 1, so times a third. So we have this plus c, and that's going to be our answer of the integral. So let's simplify it further. You can already see that a half times 1 over 3 is 1 over 6. Alright, moving on to question number 7. Now we have x squared plus 1 over x cubed plus 4x squared plus 3x. So we have to integrate this, and we have limits of 3, 1. So this is actually a definite integral. So now we are asked to solve this. Now first of all, clearly this is a proper fraction, so that is good. But next we have to ask ourselves whether this value at the denominator can still be factorized further, and we can actually say that yes, it can. So we can already say that we can actually factorize out an x. When we factorize it, this is what we're left with. But then this can also be simplified further. So when you simplify it, we are left with, because this value, the quadratic equation becomes x plus 1 times x plus 3. So now we have it in linear form. Alright, so next we're going to let this equation be equal to, we're going to add the constants a over x plus b over x plus 1 plus c over x plus 3. So now next we find the LCM. So the LCM shall be this, and then this shall be the values at the numerator. Alright, so next the denominator values cancel, and this is what we're left with as our main equation. So now when we are working with elimination, we can already see that if we want to find the value of a, all we have to do is to let x be equal to 0. Then next, if we want to find the value of c, all we have to do is to let x be equal to negative 3. Then if we want to find the value of b, all we have to do is to let x be equal to negative 1. So these are the values we're going to let x be equal to. So if x is 0, we have 1 being equal to 3a, so which a shall be equal to a third. Then if x is equal to negative 1, we have 2 being equal to negative 2b, of which b shall be equal to negative 1. So if we let x be equal to negative 3, we shall have 10 be equal to 6c, of which c shall be equal to 5 over 3. So therefore, this is what we have as our partial fractions. So simplify it further, and this is what we end up having. So this is going to be our partial fractions. So now we're going to integrate the partial fractions. So this is what we end up having. So this is how they look. So now we already clearly said if we integrate this, so this can be integrated directly. It shall be equal to a third ln x. Then when we integrate this, we shall have ln x plus 1. So here I use U substitution for this part to become ln x plus 1. And then when you want to integrate this part here, we have 5 over 3 into ln x plus 1. So U substitution also works right there. So now we'll have this, but because it's a definite integral, we have the limits 3 and 1. So now we're going to make sure to insert the limits. So insert the limits, we have the values that have the limit 3 minus the values having the limit of 1. And this is what we end up having. So when you simplify that further, this is how it looks. So let's actually open brackets. So let's insert the negative. You can see that this plus, this negative sign becomes a plus, and then this plus sign becomes a negative. So I can also already see that clearly ln 1 is 0, so that actually already cancels. So now what I can do is I can actually bring terms that actually look alike together, and that is okay. Simplify that further. Then this is what I end up having. Ln, a third ln 3 minus ln 2 plus 5 over 3 ln 3 over 2. So this is actually how they look in a simplified version. But it would also be okay if you actually just press these values in a calculator and get decimals. That is still fine. It still works out. But this is going to be my final answer. Alright, so let's look at a question from UNEB 2004, and this was question number 8. So this is an example of a question where partial fractions is basically just one of the steps. So this is an example where we need half angle substitution, but then later on we'll encounter some linear factors which will need to be converted into partial fractions. So this is where it's just a step, but let's look at how we solve this. So this was question from UNEB 2004. So being told that use the substitution t is equal to tan x over 2 to evaluate the integral of 1 over 3 plus 5 cos x dx. So how do we solve this? So first of all, by tangent half angle substitution, we know that dx shall be equal to 2 dt over 1 plus t squared, and then we're going to see cos x is equal to 1 minus t squared over 1 plus t squared, and then where t is equal to tan x over 2. So now if this does not make sense to you, just look back into my video that talks about tangent half angle substitution or Weierstrass substitution, something like that. So now this is how it will look so when you substitute in the values. So now you can already see it at the top, this multiplies and goes to the top. So now at the bottom we can actually find the LCM, and this is what we have as the LCM at the bottom. So this and this cancel and we're left with 2 over that. So at the denominator, the next step is to open the brackets. So when open the brackets, we have 3 plus 3t squared plus 5 minus 5t squared. So when you add the different values, we'll end up with 2 over 8 minus 2t squared dt. But you can already see that I can factorize out a 2 from the denominator. So this is what we end up having. So we have integral of 1, because the 2's cancel, we have 1 over 4 minus t squared. Now this step is actually very unique, because I can already see that there's actually a difference of 2 squares at the denominator. So that's going to be one of our next steps, but that means we're going to express it as partial fractions. So in this case we don't apply any other substitution method, but it's clearly partial fractions. So now we can see that there is a difference of 2 squares. So 1 over 4 minus t squared is the same as 1 over 2 minus t times 2 plus t. So now this is clearly, these are linear factors. So these have to be expressed as partial fractions. So we're going to let 1 over 2 minus t to 2 plus t being equal to 1a over 2 minus t plus b over 2 plus t. So this is what we end up having when you find the LCM. So the denominators cancel, and this we're left with 1 being equal to a into 2 plus t plus b into 2 minus t. So we can actually already set, if we want to eliminate b, all I have to do is to let t be equal to 2. Then if I want to eliminate a, all I have to do is to let t, if I want to eliminate a, all I have to do is eliminate to make t be equal to negative 2. So one of those two will allow us to solve these partial fractions. So now if t is equal to 2, we have 1 is equal to a into 2 plus 2 into b plus 2 minus 2. So we have 1 is equal to 4a, of which a shall be equal to a quarter. So now next, if we let t be equal to negative 2, so we'll have that, and then 1 shall be equal to 4b, of which b shall be equal to a quarter. That's what we end up having. So now we have a and now we have b. So therefore our partial fractions can be 1 over 4 into 2 minus t plus 1 over 4 into 2 plus t. So now that we have it in form of partial fractions, now we can actually integrate it. So now let's integrate these partial fractions. So now we can already see that we can actually factorize out a quarter from both, and then when we integrate, you can already see that these, when we use substitution for these, we'll have ln 2 minus, actually we'll have negative ln 2 minus t. Use substitution here and you have ln 2 plus t plus c. So we can already see that I can actually rearrange this, and we'll have ln 2 plus t minus, because of this negative sign, we're going to actually rearrange it. So we have ln 2 plus t minus ln 2 minus t plus c. Then this further, from our laws of natural logarithms, you know that when we actually subtract laws, it's the same as this divided by that, and this is how they are expressed in a more simplified version. But we remember that t is equal to tan x over 2, so we have to express the final answers in terms of x. So we end up having the integral of 1 over 3 plus 5 cos x dx shall be equal to a quarter into ln 2 plus tan x over 2 over ln 2 minus tan x over 2 plus c, and that's going to be our answer. And then here's an exercise for you to try out. These are special questions. I've given you answers on the right hand side for you to compare with what you get, to make sure you're actually on the right track, and to make sure that you actually have a better understanding of integrating partial fractions where there is actually linear factors involved. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If you did, feel free to tell me below in the comments. I'll make sure to get time to read through your comments and to reply to you. And also, if you're new to this channel, I encourage you to join the community by subscribing. And then make sure to hit the notification bell so that you get updated every single time I upload a new video. Again, my name is Emmanuel Olega. Thank you so much for watching. See you in my next video.